tonicity. This book isn't saying directly what it is, but they're explaining the system. It is about that inside of a cell and outside of a cell there's a different osmotic pressure, therefore a different amount of osmosis, and that all is because there's a different percentage or concentration of water and solutes inside of the cell in the cytosol, and in the extracellular fluid outside of the cell of water percentage or concentration and solute. Other things with water, only water can go as osmosis through the impermeable membrane, which is only letting water through in the process called osmosis. And that all is tonicity, with the whole thing happening there. It can be isotonic. There is the same amount of solutes outside of a cell in the extracellular fluid as on the inside in the cytosol. And therefore the same amount of water is going in and out. The water wants to go to the place where is a lower concentration of the water. Because through the same amount of solids in and outside of a cell, it is going the same amount out to the other side. And there's the same osmotic pressure, so the pressure which would be necessary to push the water back, which has come in because there's a greater amount of solute, therefore a smaller amount of water, and therefore the water wanting to go over there. The pressure necessary to get back. Which isn't happening because it's isotonic on both sides the same. It can be then hypotonic, and there is then a lower amount of solute in the extracellular fluid, so higher amount of water. So the water wants to go into the cells, it goes into the red blood cells, for example, and they are bursting. That is called hemolysis. The other way around. Hypertonic, there is a greater amount of solutes in the extracellular fluid, therefore less water, therefore the water wants to go from inside of the cells to the outside, and that causes the cell to shrink. That is crenation, and it's also not good. And therefore intravenous injections are isotonic, so that the same amount of solutes is then in the intravenous injection as on the inside of the cells, so that they're not having different amounts of solutes and they're going shrinking or bursting, but they're staying the same. And that whole system is tonicity. That is according to Gerard and Sandra Grabowski's Principles of Anatomy and Physiology book on the page 68 and 69, but this is no medical advice and also no substitute for medical knowledge, and the positions and views expressed are the ones of the source and don't necessarily align with the ones of the entities spoken of.